Alright, so let's take a look at this problem. Maximum number of points with cost. We have looks like we have some kind of matrix, n times n, zero index, starting from zero. You want to maximize the number of points you can get from the matrix. To gain points, you must pick cell in each row. Okay. Pick cell coordinates RC or at RC to your score. Okay, yeah, okay. Makes sense. However, you will lose points if you pick a cell too far from the cell that you picked previous row. For every two adjacent RC plus 1, picking cells at coordinate RC1 plus RC1 will subtract C minus. So every time we get one column away, we will have the different the number of columns difference subtracted from the score. So here, I guess this will be like, let's start from 3. I'll have 4 here, and then I'll have 2 here. 4, 2, 6 plus 3 is 9. Okay. But we just subtract 1 if. So yeah, every row we just recalculate or change the head or something like that. We change that. Yeah, we change it. So here, do we have to try every possible way? Which would take a lot of time. Yeah. So because there are like different possibilities. From 1 you can go to 1, you can go to 5, you can go to 1. And from 1, if you go to 1, you can go 3, 1, 1, 1, 5, 3, 1, 1, 1, 1, 3, 1, 1, right? So there are basically n for, let's say that n is the number of rows, columns, n to the power of m will be r. Yeah, that will be our complexity if you want to run a for loop, not 3 for loops, but if you want the first search. Because of that, what are the constraints? Well, it can be okay, n points. Okay, in between 10 to the power of 5. Okay. Let's see. If we store the best way to come to this location, then it would, yeah. Okay. I think there's a better way to do this. We just, okay, we don't care about the path, we just care about the value. So we don't have to perform things like that. But if we, okay, one second. Okay, so let's think about this. If we calculate the maximum point we can get to this point. Now do I have like okay this? So for here I can count from here, which makes it 1. From here or like from here I can have 1. From here I can have 1, and from here I can have again 1, and we have 1, 2. So now, I'll have a 1 array, 3 array. So I'll store 2 here, and then I'll start calculating this. So from here I'll have 0, from here I'll have 2, from here I'll have 2, which will make it 7, right? And then again, same thing, this will be minus 2, this will be 1, this will be 3, which will make it 4. And then what will happen is that I will have my, this will be my new array. And then from here, I'll calculate this. So I'll calculate this part taking this from here, like from back, from here to here, from here to here. So from 2 you'll get 2 plus 3, or yeah, 3, that's wrong. So I have 3, 1, and 1, like that. So from 2 I'll get 2, and maximum of 5, this will be 5. So it won't be 5, but I will have 5 from this. From here I'll have 9, and from here I'll have 3 minus 6. The max of this is 9. This will be, so this will be written back here, 9. And then but no, you cannot write it there because you have to write it later on because you want to finish these parts also. So I will need 3 I'll need 1 row to store the max current row. Okay, so my current row will be equal to the list. I can just do it like this. I guess points and then 0 and brings current row. Let's see if that works. List points. Okay. So now, what I want to do is for every row, which I will be calling I, in range, what is the number of rows? It is the length of points. For every row, I'll just go over this, and in the first row, actually I don't need that. First row, just go over this, make that, then return the max of current row. So for instance, let's say that if we have just 1 row, we just return the max there to, yeah. And here we're trying to maximize the current row, which will be using the previous row, which is actually the -1. So current max, so for every j in range, this will start from 0 and points 0. So for 1 we are trying to calculate this, and current max will be equal to max. We'll take it from the current row. So this is the current row, this part, and I want to take it from that, like that. And so for that, the current row, so difference will be So diff will be equal to absolute value of um, oops, j minus I. Okay, to here, and I just add the diff here minus diff here, so I add I, so j will start from 0. If 0, diff is I. So this will be actually like for every current row. Okay. So to calculate the current row, it does the same thing. So from the current row, this is like previous row, and also current row. Okay. So we take from the previous row So my current row will be this. Okay, I'm a bit confused. So I start from this part. Okay, I'm a previous. This part is my current. So here. Okay. My current row is points and R, like that, and then for every from T, like this, every current row, I want to change I. So like this, if current r previous row I actually don't need this because the if previous row means that if r minus 1. So points I r minus 1 will be the previous row. So this will be like that. Minus diff is greater than current row and I. In that case, we just put that here. So as you see here, we start from this. My current row is that. My previous will be that. We come here, I is 0, j is 0. Calculate the difference is 0. Here, this is 0. And I check the previous points with j. So I is that, j is the same. Okay. And then we check it. If it is, we'll just put it in here. And so yeah. I actually don't even need the control, which I can just use the R and J. Actually R. So this will be my R. R is 1. I is here. I. This is J. And we calculate that. And then I put it here, if possible. So I put it 2 here. And then we check it from here, 2, 2, there are 2. It's greater than 2, we just put it there. Increase the I by 1, start again. J 0, 1. The difference is 1. Minus 1 from J. If it is greater than the current plus. So here, plus the point R and I. Okay. I sum it, put it there. If possible, if it is greater, then when I do that, it is just simply going over it, and I will stop when, as you see here, when this is at the last row, we will just stop, and here I just want to, it should not be the, okay, I'm just going to have n is equal to points, and n is equal to number of points, 0. Let's put it here, let's put it here. This is m, this is m. Okay, and here I want to return the points in last row and max of last row. Okay, let's see. Syntax error. We get this. And then current row. This should be Okay, this should be greater than this. And now, from that, diff plus that, or minus, well, this should be J. Okay, 19. For every row, we just go in for I, 0, I, the only difference is that minus 1 J. Oh. Hmm. Um, okay, yeah, this should be curl max. But I should just make it here, here, there, to there. Okay, I just update it there. I just update it at the end because I don't want to, yeah, I will otherwise have something different. Come here, turn to max. Turn max. Okay, that works. Let's try a few examples. This is one. We tried that, I guess. Okay, now it works. So let's see and talk about the complexity maybe if it passes. 2 minutes. Time limit exceed. Why is that? Because this is n times n, n times n squared times n. But there is a better way to do this. Those. Okay, for every row, taken from there, 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 there. Hmm. From top. A second. Okay, so I just completed the code. I forgot to open the recording, but it just took like 5 minutes. What I did was that, so here I'm just gonna go back. I had these two for loops instead of this. So every time I was doing n times m, which means m squared times n, but it's it is the limit is exceeded, the time limit exceeds. Because of that, there I have to create another dynamic, like solve the sub problem in a dynamic way, which required me to create two, like not creating an array, but it required me to um, go like for this part. Let me show you. Just delete this. So normally I was checking from all possible ways, but now I'm going from left to right, 1 minus 1, and if it is 1 greater than 2, I'm putting it in there. If it is not, I'm not putting it there. And then going from left to right again, 2 minus 1 is equal to 1. Is it greater than 1? 2, 3? No, it is not. And from right to left, I'm going like that. So because of this, I'm saying that the best possible um, we can add at this index, and we're then directly adding it to below. This way, as you can see, the complexity will be just time of n times. Here, it is just m plus n plus m, right? So it is just n times n. So yeah, and spaces, of course, this is all of 1 because we're not using any additional space, we're just changing it. So this is pretty good answer to this problem. I don't think this is a medium question, I think it is a hard problem.
because it requires a BP solution in subplot problem. So BP here and also BP here. Yeah, that's why I think it's that hard. So yeah, for now, anything else I want to add? No. So I guess that was it.